So in this part of this video, I'm going to show the simulation results and everything that we have done for this project. So first of all, I'm going to show the character geometry simulation. So my laptop is sitting right now in the directory of the character geometry simulation. So I'm going to go ahead and load the training file. So this is my training skeletons over here. We're going to go ahead and select it. It's loaded. Now if we type who, we're gonna see all the possible image show with the possible combinations of the characters over here. I'm gonna display um, some of the those characters. For example, I want to see the second variation of K. There you go. You can see this. If I can make it big, yep, there is a thing. It's recognized the character K. Now, if you want, I can show another one. Suppose C, and I want to see the third variation. So there's the letter C. And yeah, so this is how you can train the algorithm with the letters with the training sets, and then we can detect the letters. So there are details codes I cannot explain because of time constraints, so I'm gonna move on and show some other simulations. Suppose moving on to the neural networks, we're gonna look at the backpropagation neural networks. We're gonna run this code and it should come up with the neural network training tool. There you go, neural training tool, and it already came up with the iterations and everything. You can see the performance over here. This we will discuss in the PowerPoint presentation once we go back. So you can see the training set over here with the epoch, the replica 71, and we can also see the regression, and these are on the value of 0 over here. So okay. Now I'm going to move on to the other one, which is the neural networks and linear vector quantization. So again, we're going to run this and it's to see the iterations are going on and the performance it's measuring. So once this is done, we can see, okay, it's done. So we can see the performance over here, which is see the train and best. Then we can see the confusion matrix. We have the training confusion, the validation confusion, the test confusion, and all confusion matrix over here. And we can see the ROC, or the receiver operating characteristic over here for the training, validation, test, and all of them. So I'm gonna close this and we're gonna go ahead and see the last one, the last of the neural networks that was in our project is the self-organizing maps, and we're gonna see. So this is the neuron positions, which is the wave vectors. It's shown in the center over here, red dotted red in the 3D space. So we're gonna see that this is the basic topology of the self-organizing network, and the neighbor connections we can see over here. The neighbor distance, the biggest measured over here in red. The input planes, which I will show in details in the PowerPoint, not the details though. So this is the weight position. So this is basically the uh, self-organizing maps. I'm gonna move on and show the last one, which is the gray level difference method. So if you run this code, we'll see that it should come up. It is the mammogram that we have used. This is mammogram for a patient, and these are the PDFs. The gray level difference is from 1, from 2, from 3, and from 4. So I'm gonna go ahead and close this, and I'm gonna go back to the PowerPoint presentation to show the results and simulations. So here you see that this is what we have shown for the simulation of the character recognition. We have trained it with more than 600 input images, and we have also tested it on 135 images. Only 6 were wrong and the rest were correct. And as I've shown in the MATLAB code, here you go, the example of the recognition of 2 alphabets. So this is the backpropagation simulation where we show the toolbox for generating characteristics, graph for different neural network, and over here we see like the best training performance we get is like 0.009988, which is really good. So Next on, as we showed for the simulation of in MATLAB for the linear vector quantization, with the training confusion matrix, the validation confusion matrix, the test confusion matrix, and combining all of them have the confusion matrix, and also show the receiver operating characteristics for LVQ. The last of the neural networks is a self-organizing map, where the weight vectors is shown in red dot in 3D space. Topology is shown on the left hand side, and at the bottom we can see the neighboring connections of the topology. The gray level different method, where you show the input mammogram image, and the PDF forms that we have already discussed in the theory section, and they all follow the theory. So lastly, we came up to the conclusion. The conclusion, which we say that the comparative analysis is presented in details for different feature extraction methods for texture and character recognition. So the character recognition method is using the alpha geometry was described, and relatedly, there are three other neural network methods such as the backpropagation, the linear vector quantization, and the self-organizing maps were brought in focus. Apart from this character recognition, we have this texture recognition technique such as gray level difference method concept was presented, and last but not the least, all feature extraction techniques were simulated in MATLAB, and the results were graphically presented for proper comparison. So that's it for the project presentation. Thank you very much.